mix a liquid and a liquid. Today we are going to look at a situation where we have two different states of liquid. For instance, we have hot water here and we have cold water here. This is an everyday activity. This is something we do in our various homes. Now, if you mix this hot water with cold water, you are going to have warm water. Now, let's assume before you mix, the temperature of this hot water is what we call theta H. The temperature of cold water is what we call theta C. The temperature of warm water, we'll call it the final temperature. Please take note of these terms. Now, if we mix hot water with cold water, two things happen. There is going to be heat loss by the liquid. By the time you mix, the hot water is going to lose heat to the cold water, and this cold water is going to gain heat. Now, once this is done, in heat transfer, the heat loss is proportional to the heat gain. The amount of heat that is lost is equal to the amount of heat that is gained. At the end of the day, after you have mixed, this is what happened. The amount of heat loss will be equal to the amount of heat gained. Now, we agree that the quantity of heat is equal to mass times specific heat capacity times the change in temperature. Now, for heat loss, our heat loss here is on this hot water. You can see this is the mass of the hot water, the specific heat capacity of water, and the temperature of this hot water, which is theta H, minus the final temperature, which is the temperature of the mixture, is equal to the heat gain, which is by cold water. This is the mass of the cold water, specific heat capacity of water, and the final temperature minus the temperature of the cold water. Now, this is final minus cold because the temperature of the mixture is higher than the temperature of the cold water. Now, we have an example on the board which can help us understand what we are doing. We are asked to calculate the final temperature of the mixture, which is this, of 250 grams of water at 65 degrees Celsius is added 150 of colder water at 5 degrees Celsius, where the specific capacity of water is 4,200 joules per kg per Kelvin. Now, if you look at the solution, we have the various masses given to us. The mass of cold water in the question there is 150 grams. Now, if you look at the specific heat capacity, the specific capacity is in kg. Therefore, we will have to convert this gram to kilogram. And in doing that, we divide by 1000. Now, by the time you divide this by this, you will have 0.15 kg. Now, let's go back to the question. The final temperature of mass 250 grams of water. This is the temperature of hot water, which is 250 grams. The mass also is in grams, so we divide by 1000. It's going to give us 0.25 kg. Now, let's go back to the question. The temperature of the hot water is 65 degrees Celsius. You can see it here. Theta H is equal to 65 degrees Celsius. Then we have 5 degrees Celsius here as the temperature of the cold water. You can see it, 5 degrees Celsius as the temperature of the cold water. We are asked to find the final temperature where specific capacity of water is given in the question. Now, mathematically, heat loss is equal to heat gain. From our equation, we have this on the board. Now, if you substitute the variables into our equation, the mass of hot water is 0.25. The specific heat capacity of water is 4,200. The temperature of hot water is 65. We are asked to find the final temperature, which is theta F, equal to the mass of the cold water, which is 0.15, times the specific heat capacity of water, which is 4,200, final temperature unknown minus the temperature of the cold. Now we can stripe out the specific capacity of water. Since both of them have specific capacity of water, you can stripe them out, remove them, eliminate them. You are going to have 0.25. You open this bracket. In doing that, you multiply this by this. 0.25 times 65 will give us 60.25 minus 0.25 times theta F will give us 0.25 theta F equal to, expand this, open this bracket, you have 0.15 times theta F is going to give us 0.15 theta F minus 0.15 times 5 will give us 0.75. The next line we are going to collect like terms. We have 16.25. By the time this moves to this place, it becomes plus. It becomes plus 0.75 equal to 0.15 final temperature. Final temperature plus, by the time you move this to the other side, it becomes, this negative sign becomes positive. You have 0.25 theta F. Now we have collected the like terms. 16.25 plus this, if you add this, you're going to have 17. Now if you add your theta F, it's going to give you 0.4. Now let's make theta F the subject of the formula. You divide both sides by the coefficient of theta F, which is 0.4. By the time you cancel out, divide 17 by 0.4. Our final temperature is going to give us 42.5 degrees Celsius. I hope this is clear. Thank you for watching. See you in the next class.